I'm a PhD student from the University of Amsterdam. And actually participating in this task has been a new experience for me, and the working notes paper is my very first paper. So many thanks to the organizers for this very valuable learning experience for me. And I'll be looking forward to new HIPE challenges in the future. All right, so we participated in two task bundles. The first one, coarse-grained named entity recognition plus end-to-end entity linking. And the second one is entity linking with given mention boundaries. And for this second task, we collaborated with our colleagues from the Radboud University who developed the REL entity linking system. And I'm going to describe it a bit later. All right, so the first bundle, we did mention detection, we targeted all three languages, but the main focus was on English. And we did mention detection separately from entity recognition because with just three classes, it's a bit easier. So we view entity recognition, classification, and mention detection as two separate instances of the same problem, the token classification problem. And we have 11 classes for NER and just 3 classes for mention detection. And for entity linking, we used an English-only Wikidata dump indexed with Elasticsearch. And this is an important limitation of our approach, that we only used English Wikidata, but still it somehow works. And also we considered only the literal sense of the entities. So a bit more about token classification. We used BERT models, which is a very popular choice among the task participants. Two base models, one for English and one multilingual. Yep. Shall I maybe? Yep. Brilliant. The training data for German and French, there was enough data provided within the task. For English, we needed more data, so we used CoinLL dataset. And with the BERT models, we used simple majority vote ensemble of the models which are trained with a different number of epochs and different random seed values to prevent overfitting and improve the performance. So the results for named entity recognition here are above the baseline, but below the top results and slightly above the median. So we can see that it works all right, but just this simple approach is probably not enough for the noisy historical data to achieve top results. All right, so entity linking. For candidate retrieval, we simply searched in the Elasticsearch index, combining full text search with precise matching and preferring precise matching, which is not always the best idea, as we'll see later, but on this stage it was like that. And for ranking at this step, it was also very simple. We used the scores provided by Elasticsearch, and if there is a precise matching, we would put the candidate before other candidates. Later it was changed, but with the results, there is an interesting observation that while German and English are, well, not great, but still above the baseline, French is below the baseline. Why is that? So we know that token classification was working all right, also for French. So I assume that this is some interesting linguistic thingy going on here, which is English and German are a little bit closer together, but if you try to search for French entities in English Wikidata, it is worse. So just some observation about that. Some things can be improved in the future. There are several directions for future work. For token classification, we could perform more extensive parameter search when there is no time constraints, because training burst takes time. and also train more advanced base models, transformer models such as Roberta, Robust BERT. And also a very important challenge of the task is OCR noise. So if we can deal with with this challenge, it is going to improve things a lot. So for entity linking, well, in English and mostly, and a little bit in German as well, we had a lot of false positives for nil entities. So for example, there is some Mr. Smith from the end of 18th century mentioned in the newspaper, and we link this guy to some modern person because it is retrieved and it matches, but apparently the correct answer is nil. So especially for the especially in English, especially for the person class, it is happening quite often. So a nice improvement would be to improve nil detection and maybe to use entity types as features, because for example, if there is location entity type, then the probability of it being nil is lower than if it's a person. Candidate search can be improved. Elasticsearch has a lot of settings and can use embeddings for search. It can use a lot of things. And I was using just the very basic settings, so there is a lot of things to play with. And obviously, multilingual Wikidata for multilingual tasks is much better than just English. But we only used the English one this time. But in the future work, it would be interesting to try different ones. All right, so bundle 5. So the first two runs that I prepared myself were, in terms of candidate retrieval, similar to what we did in bundle 2 in terms of entity linking. For the second run, I tried adding historical word variations using a library that is based on machine translation techniques. But ranking was completely different this time. So we had two assumptions. The first one is that context-aware embeddings are working well for capturing the meaning of the sentences. And the second assumption is that a description of an entity is semantically close to the entity itself. So basically, the description is sort of a synonym of the entity of its mention. So we take the description of each candidate and we replace an entity mention in the sentence with the candidate description, and we get a new vector. And if this vector doesn't take us too far away from the initial one, then the meaning hasn't changed too much, and so probably the candidate is a good one. So we compute cosine similarity as the main score, then we multiply it by the Levenstein similarity ratio for the labels, so between the mention and the candidate label. Again, to prefer precise matching, but not as much as previously. And we used pre-trained Flair embeddings provided by the organizers. On top of them, we used, to embed documents, we used LSTM-based embeddings also from Flair. Oh, and I haven't mentioned yet, this time it's only for English, yeah. So the results are much better at 5 than they are at 1, which is because the submission was not optimized for just one best candidate. And an interesting thing to notice is that when I tried historical word variations, it didn't quite improve things. And this is because it introduced more noise. So apparently the algorithm that used for generating these variations was trained on some rare spelling variations, and trying it for every entity, it just adds a lot of noise. So instead of improving the performance, we can see a slight performance drop here. But I guess if we find a way to determine if an entity is likely to have changed or not, and then only after that we generate new candidates, additional ones, historical variants, then it could work much better. So moving on to the REL system prepared by our colleagues. REL stands for Radboud Entity Linker, and this is a modular system. Candidate selection here is twofold. So the first two candidates are selected using pre-computed mentioned entity priors, which are based on Wikipedia and cross-wiki corpora. And then the next three candidates are chosen based on contextual similarity in a slightly different way than what we are doing. And then disambiguation is performed. And here it's the main difference from our approach is that they are using collective disambiguation. So not only local compatibility is important, but also global coherence of the entity linking decisions within a document. And the results are quite nice. So in terms of F-score, it shared the second place. So we can see that, and by the way, REL was not directed towards historical data. So we can see that a collective disambiguation system performs quite well, even like out of the box. And it leads to a possible conclusion that collective disambiguation is a nice approach, especially for historical data. So this is what we want to try in the future. Other things to try in the future are different embeddings, like fast text ones provided within the task, and again, dealing with OCR noise, improving candidate search, and so yeah, there are some directions that can improve the results in the future. So I guess, yeah, that's it. Thank you very much for your attention. Thank you again for organizing the task. It's been really a nice experience for me. So yeah, questions, comments.